All right, so this is the module 3 of the 1 month free AWS essential. So in today's class, we're going to be talking about compute, which is one of the major services in AWS. So under compute, there are a lot of resources, but the main resources that we're going to be looking at under compute is AWS EC2 instance. Before we start or go deep into the topic, let's look at what we're going to cover. So we're going to have the review or overview of the AWS EC2. We are going to look at the types of EC2 instance, the Amazon EC2 pricing. Then we're going to also talk about auto scaling in AWS. We'll talk about load balancing in AWS as well. Then we'll also talk about AWS messaging service and explore some of the serverless compute services on AWS and AWS container services. Then we look at the knowledge check. We have some knowledge check. So at the end of the course, what you are seeing on the screen is going to be your objective. So we're going to understand or learn more about the advantage of EC2. We're going to recognize the different types of EC2 instances, because if you want to pick an EC2 instance, before you pick one, you must know the different options that you have. Then with that, you can select a specific one that is useful or that is going to be used for your application or the requirement. We're going to be able to explain the different billing options. One of the major things that you want to have at the back of your mind before you configure or pick any of these AWS services is the pricing, because they say cloud is cheap, but it is only cheap if you actually know what you are doing. If you just pick any service and you don't know what's the pricing behind it, it may be too expensive for your company. So you want to actually understand the pricing. And there are a lot of ways that you can minimize or optimize your cost in AWS. Like if you have a server that is going to run for entire 1 year, then there are ways that you can use to reduce the price, because it's going to run for the entire 1 year. So you don't have to pay the exact amount that somebody that just need a service or a server for 1 day. You can't pay the same rate that the person that is going to run the server for 1 day or for 1 month with the one that you are going to run it for like a whole year or 2 years. So you need to understand the different pricing option. We're also going to understand how to the advantages and how to create an auto scaling goal. If you have one instance and if the workload on that one instance is getting too much, then you want to have another instance that is going to complement the one instance that you have. And if you create 2 instances, there's possibility that after some time, the people that are using the 2 instances, they won't be there again. So you don't want the extra instance that was created to just continue running, because that will waste time and money. So you want to automatically turn it off. So the way you can create an instance automatically and decommission it automatically is by means of auto scaling. So you want to understand that. And when you have 2 or 3 instances in your account, when you have 2 or 3 instances, you also want to be able to distribute services to all of these instances. So you can do this with the help of load balancing. And when something happens to your instance, maybe somebody is connecting to your instance where they don't supposed to connect to it, or your instance is running at a very high capacity, more than what it should, you want to get notification even if it is in the middle of the night. So all of these, you can set like an alert that is going to notify you. And with the help of Amazon SNS, you can actually do that. So these are all the objectives that we're going to learn after you cover the topic that we have in this section. Somebody raised his hand up.
Yes, I'm the one. Um, you talked about you mentioned about auto scaling, and you said that creating another instance to auto scale. I just want to get clarification. When you auto scale, is it by you create an instance to where you can scale into when it's probably the one you have in is overwhelmed, or the um program, the memory of the one that you have, like the memory, the storage, depending on what you are still scaling, are those ones that's going to be increased, or is it the features in the one particular instance that's going to be auto scales, or another instance will have to be created entirely to accommodate the scaling difference? I don't know if you get my question.
Yeah, I get your question. And this can be actually achieved in both ways. In auto scaling, we have what is called scaling and we have what is called scale out. And at times, some people call it scale up or scale down. So there are times that, and some circumstances whereby if you need an increase in your capacity, there are times that it's always better to just modify the existing one. For example, if you have a server that is overused, and maybe it's because there are too much people saving like resources or saving file on that server, it might be a better option instead of to add an extra server to make it two. You might just decide to change one component of the existing server. Maybe you can decide to increase the storage to a bigger capacity instead of changing or instead of adding a new server. So there are times that you either scale horizontally or you scale vertically. When you scale horizontally, that means if you are using one server before, you can add another server, making two. Then if that two is not enough, you add one more to make three. That is what we refer to as horizontal scaling. And that is what is also called scale out. There are times that you can do vertical scaling. So when we talk about vertical scaling, that is when if you are using one server and if the server is overwhelmed, instead of going to add a new server, what you just need to change the components or one of the components of the existing server. So it's still going to be the same server. It's just that you are going to increase the capacity. Maybe if initially the CPU size is just 2 CPU, you can change that 2 CPU to like 12 CPU. It's still the same instance, but you just increase the capacity. And all of this, we are going to discuss it in the class. So there's no cause for alarm. There is provision for all those. All right. So the first topic that we are going to look under this module is let's take an overview of EC2 service. Like I said earlier, EC2 is one of the major service in AWS. I can put to you that if you put 100 people or 100 companies that are using AWS platform, 99% of them will be using EC2 in one capacity or the other. So EC2 is a feature service that you need to understand a lot. And EC2 has a lot of resources. So initially, let's take a step back and let's look at what we have before EC2 and the components of the resources. The components of the server before EC2. So let me bring out, let me see if I can do. I just want to have a plain sheet that I can like draw something on. So initially we have server, like regular server. And if you want, you can actually refer to this as your regular computer. So okay, I have my blank page. So initially, we have a server. Let's just say this is your regular computer. Inside your regular computer, you have what is called core, or we have what we call, let's see, this is, one second, let me close this. So let's say this is like, okay, this is not drawing yet. Let's say, can this one, can you guys, oh, it's not showing. My pen is not writing. Hey, give me 1 second. Let me quickly set up this. I don't know why it's not writing, but let me look at it quick. And yeah, it's working now. So initially what we have is, let's say you have a server. This is your server, like your normal computer. Let's say this server is what we have on-prem. In this server, we're going to have CPU, which is called central processing unit. We're going to have memory. You're going to have storage. Then you're going to have like networking. And this networking, we can call it like the network interface. Oh, I said iNet. Hold on, I mean, that's not correct. Let's just say network interface. And we're going to have some security devices or security components like firewall, and another one that we can have is the authentication. That is like if you password the computer or the server. So these are the normal things that you have in your on-prem server. So when you now decide to use cloud, if you now decide to use AWS cloud now, because you are not using your on-prem again, all of these requirements that are on your server, you can now customize them. You can now customize them. So AWS gives you the capacity to customize all of this. And the way that you are going to pick a, you know that this server, the data center is not yours again. So for you to spin up the same server on AWS data center, there are some things that you have to do. You have to give those server parameters to AWS so that they can use the parameter to spin up a server for you on their own data center. So the way you are going to do this is that they provide you a form that you need to fill. So inside the form, you have to say the capacity, the CPU capacity that you want to use. And that CPU capacity in AWS is referred to as vCPU. So you have to tell them the capacity of the vCPU that you need. The memory, you have to tell them the capacity of the memory you need. Maybe you need a server of 12 gigabytes. 12 gigabyte. You have to tell them the storage. Maybe the storage you need is 1 terabyte. You need to tell them the network interface, like the IP address that you want to use. The firewall configuration, you have to give them the firewall configuration. And AWS have names for all of these. So for example, the firewall configuration, they have for the server, they call it security group. And in your normal server, in your normal environment, you just call it firewall. But AWS call their own security group. Either you call it firewall or they call it security group. It's still the same firewall. Then the authentication. In your own environment, you might use username and password. But AWS provide like, okay, this username and password is not secure because somebody can guess it. So they now say, okay, we don't by default, you can't use username and password. What we are going to give us is a key pair that if you want to sign into your username, to your server, you need to provide us a key pair. A key pair is a key, a two key that one is private key and the other one is public key. So the public key, you're going to send it to AWS. And anytime you want to connect to your server from your laptop, you have to provide this private key that, hey, it's still me, I'm the one, because I have the private key. It is the public key that you guys are holding. Both the private key and the public key has to match before you can connect to the server. So everything that on-prem server has is still the same thing that you're going to have access to in the cloud. Just that the name that AWS is going to refer to them is just going to be different from the name that you call them on-prem, but they are still the same. So this is what we have on-prem. Now, if you want to use cloud, all this information, you have to provide it. You have to provide all of this information for AWS for them to spin up a server for you on their own data center. So when you are spinning up this, there are multiple versions of each of these resources. Because now you're going to be customizing your server. So there are multiple versions of CPU. You can select the CPU you want. If you want, you can say, oh, you want just 2 CPU. If you like, you can say you want 64 CPU. So you have to specify that. The gigabyte for the memory, you have to specify it. The storage, you have to specify it as well. The IP, you also have to specify it. If per adventure or if per any chance you do not specify any one of them, there are some that you must specify. If you want AWS to create a server for you, you must specify them. But there are some that if you do not specify them, AWS will use a default settings for you. And there are some that you cannot specify them. AWS will automatically use defaults. So somebody is asking that, is the key pair different from the authentication we recently set up? Yes, they're different. The authentication that you recently set up is for the account itself. It's for the AWS account. But the key pair I'm talking about is for the resources, is for one instance. one EC2 instance, but you can use one key pair for multiple instances. It's just like if you have a laptop or you have a computer, you can password it, the interface, so that somebody cannot log in on your system. So it is that login that we are talking about. So this is what we have currently, and this is how you provision them in the AWS. So back to our presentation, AWS EC2 is a service, and under that service, there are a lot of resources. And those resources are what you can use, just like how you use them in your environment. So the number one resources that you have in EC2, under EC2, is the VM. Some people call it VM, and that is your server. That is the number one resources. Under the VM, and some people call it VM, some people call it server, and some AWS refer to it as EC2 instance. So if you hear EC2 instance, it's just referring to server, like what you have on-prem. So what is EC2? What's the EC2 service? A service is a service that is offered by Amazon Web Service, and that is one of their key feature service. So it's one of the core services in AWS, and the main feature or service provided by or that you can get from EC2 is the virtual machine, which is your normal server, or we call it EC2 instance. Remember I said earlier that under EC2 compute, under EC2 service, which is Elastic Compute Cloud. Under this service, there are multiple resources, but the major resources there under this Elastic Compute Cloud is the EC2 instance. And that is why some people, if you ask them what is EC2, they will automatically tell you the definition of EC2 instance, because they believe that EC2 is also the same thing as EC2 instance. But EC2 is a service that has multiple resources. And under the resources, under EC2 as a service, we have EC2 instance, which is one. But a lot of people just categorize this EC2 as EC2 instance. So your EC2 instance, by default, it provides on-demand scalable compute capacity. And if you are spinning up an EC2 instance, which is the major services under EC2, you can, by default, you are going to be provisioning it as on-demand. So the EC2 instance, it provides on-demand scalable compute capacity. Remember, we said that in your normal data center, there are a lot of things that is happening there, and a lot of resources in your normal data center. You have some servers, and those servers that where you can host your application, they are referred to as compute services. You have storage capacity, you have database, security, networking, and so on. So these are all just categories. So this compute is what AWS referred to as EC2. And EC2 is not the only compute on AWS. There are multiple compute services in AWS, but EC2 just has to be one of them. And under compute, under EC2, which is one of the compute service, there is EC2 instance as the resources. So this is our compute. So what are the features of the EC2 instance? I mean, what are the features of the EC2? The first features of the EC2 is that you can use it for your, or it provides the instance, which is called the EC2 instance. That's the number one feature, which means that it provides a service, and which is a what? A virtual machine. This is virtual server in the cloud, like your normal server, but it's now virtualized. Then the EC2 instance, the EC2 also provide what is called an AMI, which is called Amazon Machine Image. Let's take a second back to your normal data center. If you buy a server, that server comes with some hardware. And on top of that hardware, there is what is called operating system. That operating system is actually what will determine the name of your server, whether it is Windows server, Mac server, or Mac OS, or it is Linux. So it is the operating system that is running on those hardware that will determine whether it is Windows, it is Mac, or it is Linux. So this operating system is what AWS refer to as AMI. Is what AWS refer to as AMI. That if you want AWS to create a server for you on their data center, you have to tell them the kind of operating system that you want. And AWS, if you just say operating system, they don't understand that, though they do, but they want you to use their own terminology, which is called AMI. So if you are telling them to spin a server for you, you have to provide them the AMI that you want to use. Is it Windows AMI, or an AMI that is based on Windows, or Linux, or Mac? So you have to provide them which operating system indirectly by saying this AMI is what you want. Then apart from the AMI, there is, and before I go to the next one, the AMI, you can see it is the pre-configured operating system. But there are a lot of AMI on AWS, which is a lot of operating system. Some operating system comes with some software already installed on them. Remember, if you buy a laptop, the laptop can either be Mac laptop, it can be Windows laptop, or it can be Linux laptop. But once you get the laptop, maybe when you get to it, now start downloading the application that you want on that laptop. So the same way, AWS, when they provide you an AMI, there are some AMI that we call them quick AMI, meaning that they are just AMI that it's just an operating system. There is no application or a very few applications downloaded on them. But there are also some other AMI that they have a lot of different specifically needed software downloaded on them. So if you want an AMI that already have a Python programming, that comes with Python programming, you can actually use that AMI that it already comes with Python programming, so you don't have to download Python on it. It comes with operating system and it comes with Python programming. So there are a lot of operating system that has different application or different software pre-configured. So they are all referred to as AMI. And when we get to under AMI as a topic, we are going to be discussing them in full. So after AMI, there is another feature which is called the instance type. Remember, when we said earlier that when you want to, if you want AWS to create a server for you, you have to fill a form. You have to tell them the capacity or the parameter of the server that you want. And among that, I said there is something called CPU. which AWS refer to as vCPU, which is called virtual CPU. But on-prem, you are going to call it CPU on your own server, but AWS call it virtual CPU. There is also memory, and there is some networking capacity, which is network interface. So all these three, the way AWS provide it for you to specify is that they don't want you to specify this one by one. You can tell them that, hey, I need, or the way they have already configured it, they have already configured some system that they have a specific capacity. They might have 2 vCPU, 12 memory, and maybe some 0.5 network or something like that. So they have different system configured for this capacity. So if you want to pick a specific one that fits in with what you want, you have to specify the instance type. So the instance type is another way that you can tell AWS that, hey, I want a server that has 2 vCPU or 4 vCPU. I want a server that has like 12 memory, 12 gig memory, or have a server that has 24 gig memory. So then also the networking. So the way AWS provides this, they just say, okay, just look through the list of our instance type and tell us which one you need that fits in the category that you have here. If you go to the AWS account, your AWS account under EC2, let me clear all of this so that I can see properly. Let me move this one to this side. So under EC2, you can actually check those instance type. You can see here, instance type. If you click on this, it's going to give you different instance type that you can pick from. And what differentiates them, you can see under the instance type, this is one. You can see it says this one has only 1 CPU. And this is the architecture for this. And it has a memory of 0.612. And look at the networking capacity. The networking performance is low. And they tell you how much it costs. So these are all these different instance type, and they have different vCPU capacity. So if somebody or your company has you to create a server for them, then you need to understand, okay, what CPU is going to be sufficient for the application that they want to run. And it is that CPU, compared with the memory that they need, compared with the storage, compared with the networking performance, that is what will determine which of the instance type to pick from, or which of the instance type to pick. So you can see there are a lot of them. And if you finish from this first page, you see it's page 17. So let me see. Okay, total number of them is 806 instance types. So whichever one you need, it depends on the capacity. You can see there are some that have 16 gig, some has 2, some has 8. vCPU, some has 32. You see 96, 72, a lot of them. And the higher the number, the more expensive the vCPU, the instance type will be. So if you pick one instance, one vCPU, the money will be, you can see, it's just 2 cents per hour. Now let's go and see all those ones that is 96. You see this one, $4.08 per hour. So if you spin up this one, if you use this is how much you are going to pay per hour. But if you use the one that have 1 CPU, you are going to pay 2 cents per hour. You can see that the higher the vCPU, the expensive your money is. And now, if you go a little bit further, you see this first one and this second one, both of them have one CPU. But look at the memory. The memory is different. the first one memory is bigger than the second one memory. Now let's go and look at the price. So you see the price is not the same. The first one, because it has a higher memory, the price is even higher than the second one. The second one is less than 1 cent, while the first one is 2 cents. So those are the things that you need to consider before you pick an instance type. So the various configuration of instance type, you have the vCPU, which is CPU, you have the memory, we have the storage, we have the network capacity, and the graphic hardware. Then we have the instance volume. The instance volume is the storage. This is a storage. Remember when I say when your on-prem server has storage where it keeps file. So the same way we have instance storage, which is AWS referred to as instance volume. This is the storage attached to the virtual server. There are some storage that they are physically separated from the virtual server. There are some that has to be attached to the server. So let's say this is your server now. Let's say this is server. Remember, your laptop, it has a storage that comes with it. And guess what? You can buy another external storage. So this external storage, you can plug it to your laptop, and if you save some data inside it, let's say this is the data that you save inside it, you can unplug it again and plug it to another laptop. So this server, this storage is what we refer to as external storage. Is external storage. And guess what? Because it's an external storage, you can say it is persistent. Persistent in the sense that if anything happens to this laptop that you send the information from, you can unplug the storage from that laptop and and put it here and add it to another laptop, and you still get your data, and that is why it is referred to as persistent. The same thing on the cloud. AWS provides you multiple means of adding storage to your server. We have a storage that is attached directly to your server, which is called instance stores volume, and we have a storage that you can detach or add at any time. So it is called an elastic block storage, but this is the most common one. Majority of the server that is running on AWS are using the elastic block storage, which are called a persistent storage. When we get deeply under the storage, we're still going to discuss this in full length. So these are just like an introduction into each of these components of EC2 EC2. Then every server that is in a network has IP address. Every server that is in a network has an IP address. Let's look at it this way. If you are in a community, every houses inside that community has what? Let's say this is a community. Every house in that community, what is one thing that all of them is going to have? Anyone?
Get security.
Home address, house number.
All of them, we have address. They're going to have address. And this address is how you can actually identify a particular house. If somebody is coming from a far place, you will tell them the house address. And this is how you can identify houses. You can identify houses with colors, because 3 houses in the same street might have exactly the same color. So the only way you can identify them is by their address. So when you have an address, then that means you can't lose, right? The same thing with servers. When you connect servers, multiple servers together, when you connect multiple servers together, we say they are in the same network. If you plug multiple, if these servers are all connected together one way or the other, we said that is why we refer to them as network. So the only way you can identify a computer in a network is by using what is called their IP address. So if this server now wants to send something to this server, it will use this IP address. If all of them are in this, there are also a time that they have to use the MAC address, but they use the IP address. But if all of them are to communicate together, because they are connected together, they can use what we call their private IP address. Because so the private IP address is just now, let's just say, is now like the house number. So if these houses that are in the same street, if they want to refer to another houses inside that the same street, are they going to be calling the name of the street? They're not going to be calling the name of the street. They will be referring to each other as with the number. They can say, oh, number 5, the house number 4, number 6, number 8, or something like that. They won't be saying Elephant Road, number 8, or number 8 of Elephant Road. So they won't be saying this because all of them are in the same road, but they will be referring to each other as the number. So the same thing in a private network. When they are referring to each other, because all of them are under the same network, they use their private IP. So if any of this server wants to communicate to another server that is not in the same network with, let's say this one is the external server, then for any of these servers to be able to communicate to a server that is external, that is not in the same network, it has to first connect to the what? Internet. And for them to be able to connect to internet, they need what? A public IP. And this one too need a public IP address. So if a server that is not in the same network wants to communicate to each other, they have to use their public IP address to communicate with each other. But if they are in the same network, they can use either the public or the private. But once they are trying to communicate to a server that is not in the same network, that is not connected with them in any means, then they have to go through the public. So this is one reason why when you are creating your AWS account, they believe that the first thing they give to you is private IP address, so that any other server that you create, maybe if you create 3 servers, all of them can use the private IP address to communicate. But immediately you want to use that server that you create on AWS to communicate to a server that is not in the same network, then you must attach a public IP address. This is the basic means of doing this, but there are ways that we can work around this. But it's still going to need a public IP address, but there are secure means of doing this. One way is, let's say we have multiple servers on AWS that they use private IP address because all of them are in the same network. They can communicate with their private IP, right? So immediately they want to communicate, maybe they want to communicate to my laptop that is not in the same AWS environment. That means they need public IP address. But we can put something like a proxy server here that they first communicate to the proxy server, and the proxy server is going to be using its own public IP to talk to my server. So what happened there? That means my own laptop will not know their IP address. So we're going to get there. That is like a more advanced type, but the basic one is that any server that wants to communicate to different network that is not in the same network, they have to go through their public IP address. They can't go through the private. And we are going to see those scenarios when we get to the hands-on section. And the last one, yeah, go ahead.
Yeah, so this public address you're talking about, is it the same thing as just going through any public address available, or this public IP address has to be already configured, like kind of part of the network, or it's just go through any public address that is available?
Yeah, so it's actually any public address. So the way this public address works is that this is internet. This is your private network. This is my private network. Any computer that are in my private network, like my laptop, my printer, that I've already connected together my phone, they can communicate with private IP address. While all the computers that are in your private network can communicate with their private IP address. So if any of these two networks want to communicate, you know, there are different private network. They have to go through internet. And guess what internet has? Internet has thousands, if not millions, of addresses of a public IP addresses. So if this server wants to communicate to this server, it first talk to the internet, and internet will give it one of its public address. Let's say the internet has a public address that is 12.15, then it has another public address that is 17.45, and it has another one that is 19.25. I'm just using this. Public address is actually with 4 decimal points. So if any of these two servers wants to communicate, it will first need to get one of the public IP address. So it will request for this. At times they have to buy it or request for it from the people that are in charge of public IP address, and they are going to assign this public IP address to this server here, 12.15. And they assign this one to this server here, 17.45. So now, if this server wants to talk to this server, all it just needs to do is to compose his message and send the message to the internet. This is the internet. And it will have to also specify the address that you want to send the message to, that, hey, let me send this message to 17.45. So immediately this message that goes out from 12.45 get to the internet. Internet has a record of who or which server is using 17.45. And immediately the internet receives that message, it knows that it's going to this server. So all these public IP address, they are actually being sold. So if your company wants to use a public IP address, they have to buy it. And they are buying it from the organization that is controlling the public IPs. Does that make sense?
Yes, I get it. Thank you.
All right. So the next one is the key. So, this is now, you are now using AWS Cloud, right? So on AWS Cloud, which is public, there are a lot of people that are using AWS Cloud. So one way for you to secure your server, because now I'm not in AWS data center, I'm in my house. But I have a server on AWS Cloud. So now if I want to be able to connect to this server, AWS want to make sure that the server, I'm actually the right owner of that server. So one way to identify that I'm actually the right owner is that when this server is created, they are going to password it. But because password is not that secure, they use a more secure way called key pair. So when this server is created, a 2 key needs to be generated called key pair. The key pair is actually password, but is now encrypted. Remember yesterday when we talked about encryption, but the password is now encrypted, because when you are creating, when you get to a window, you have to convert this encryption or this key pair back to password, but it is actually password that is already encrypted. That's why they call it key pair. So when you create this server, you have to provide 2 keys. And these 2 keys, you have to give AWS one to keep on this server. And the one you give them is called the public key. And you have to keep the private one. So anytime you want to connect to this server, you have to provide the private. So when AWS receives the private, they match it with the public key. If they are the same, then they will give you access to this server. But if they are not the same, they will deny your access. So key pair is another service or feature of EC2 service. So before we go into the hands-on, let's look at the types of Amazon instance type. There are various instance type category, which I said earlier. And remember, I showed you this category, like T1, T2, all of them that you can pick from. In reality, you don't just look at, oh, I need just one, and I want to need a memory of 0.612. What is the basis for you to determine which vCPU or which memory to use? So in reality, when you are working in real life, if you want to deploy an application, that application, maybe the capacity of the application or the vendor, they will tell you the kind of system that you need to run the application that you need a server for. So there are some some instance type that they can work with anything. If you don't know the kind of capacity that you need, you can go with them. And those kind of server are called the general purpose. So the general purpose, let me, even before I discuss this general purpose, one thing that determines the server that you pick, the kind of instance type that you pick, you are going to look at the price, how much it costs. You are going to look at their storage. What is their storage capacity? The network capacity and the compute capacity. So, but if you are not really bothered, like you just need a server, right? You are not bothered about the storage, you are not bothered about the compute, you are not bothered about the networking, you just need a small server that maybe to test something, then you're going to go for the general purpose. But if the application that you are running is actually for storage application, is actually a storage application, then you're going to need a server that can run very well, or that can run storage application very well. So in that case, you might need a server that is optimized for storage purposes. If it is compute, you might need a server that is optimized for compute purposes. Maybe you want to create a gaming application. Then that means that gaming application must run fast. That server that you're going to run the gaming application on must be efficient for gaming purposes. So in that case, you might be looking for a server that is optimized for compute, that can do a lot of calculations on the go. Imagine you have a server that you want to use to play FIFA soccer. Because there is a lot of things. When the player kick the ball, then another player comes in, take the ball, pass it to another person, dribble. So all those things, they are compute. It's calculation. So you need a server that is very optimized for calculation purposes, for compute purposes. So in that case, you might be going for instance type that is optimized for compute. So if you are working in real life, your organization, they will tell you what they need, or your customer or your client will tell you what they need that server for. And based on the information that we provide you, that is what is going to determine which instance type you are to pick for them. If a client or a customer tell you that, oh, we want to use this server to store some customer information, like customer data, like a database, then you might want to pick a server that is kind of good for storing information, like a storage server or a database server that is storage optimized. So when you want to pick, or what determine your picking of general purpose, is that you want to balance between compute, memory, and networking. That means you don't really care which one of them is actually big, you just need something. So that is when you balance, like, okay, I need a small compute, I need a small memory, and I need a small networking capacity. You balance all of them. That is the general purpose. That's when you pick the general purpose. And this is usually suitable for different range or multiple range of workloads. Then there is another one called compute capacity. And this offer a very high performance processor. So those ones that has high vCPU, those are, majority of them are compute optimized.
60 voice privacy contents have been updated.
Those are compute optimized. So, and it's ideal for compute intense application or batch processing workload. We have memory optimized. This one deliver fast performance for memory intense workload. And they are very suitable for high performance database because they are memory optimized. You need it for database, then you go for memory optimized. If you need it for something like storage or accelerated computing, like all these data processing, then you need to go for accelerated optimized. And finally, for storage, go for storage optimized. So those are the different ones. And if you click on this, which the file I share with you, you'll be able to see the different instance type and their use cases. Another thing that you also need to consider when you are picking or you want to spin up a server on the cloud is the price. When you pick a server, when you spin up a server on the cloud on AWS.
Can I ask a question, please?
Yeah, go ahead.
All right. I think you made mention of two storages, and then lastly, you said storage at the end of it, and then you said another storage. So it's a little bit confusing. Because at first you said you needed, when you need the one for accelerated, memory optimized, compute optimized, you said the general one is when you basically you really do not care about the storage and all of that.
Yeah,
But at
you
the
need
same
to
time,
balance, you want to balance.
yeah, you want to balance. At the same time, you went furthermore, and then you said memory optimized. That was when you need it for database information wise, right?
Yeah, yeah.
Yeah. But at this, I think it's the accelerator or something like that, if I'm not mistaken. You said something that has to relate with saving or storage, sorry. And then lastly, you said storage. So is it like storage appears twice?
No, okay, look at it this way. So you understand the general purpose that you have to balance between, if you don't know the capacity of what you need, whether it's going to be more storage intensive or more network intensive or more compute intensive, you can balance between them. Okay, let me get small of them, or let me get the adequate, each one of them are in adequate capacity. Then that's the general purpose, and that's the most common one. If you want to use, if you know that the application is more of compute, that it requires more compute capacity, then that is when you go for compute optimize. And this is when you are talking about all these high vCPU. Then the next one is memory. If you are like, okay, this instance is going to be, we are going to use it for a database that we want to install database on it. Like, we want to use this for database. Then you go for memory optimize, because you are using it to store. You know, when you talk about memory optimize our database, you don't know how many customers' information or customer data that you're going to store. So you need a server that is more efficient for database. Then the next one is the accelerated computing. When you talk about the accelerated computing, maybe you are running a batch process, or you are running like a data processing. For example, all these weather company that determine weather of a particular place. So, you know, the data is getting, they are getting the data immediately, and they are processing the data. And that tells them whether it's going to rain or it's not going to rain. When there is COVID, data is coming everywhere, and they need a very high powerful machine to quickly run the data and to give a very clear visual information. For those kind of application of requirements, that's when you use accelerated computing, because it's running data, it's calculating data, it's analyzing data, and it's giving you information in real time. When you are more of storage, that you need a server that can store a lot of information, that is storage optimized. Does that clear your misunderstanding or doubt?
Yes, sir. Yes, sir. I'm fine now.
All right.
All right. Thank you so much.
All right. So another thing, that when you want to configure or spin up a server in the cloud, another thing you need to consider is the price. Remember when we come here the other time, under instance type, you see all these prices. You might think like, oh, this is just 2 cents. This is just 51 cents. This is just $4. Well, it's cheap. But remember, majority of companies and majority of applications, they just don't create a server for 1 minute. You will see, if you go to a company, you will see a server that has been installed or launched for 10 years ago. You see a server that has been launched 5 years ago. And one thing about this server is that they are running 24 hours. The only time they are turned off, maybe they just want to upgrade them, and that upgrading might not take more than 1 hour or 30 minutes. So within 6 months or within these 10 years, they might have off them cumulatively just for 24 hours within these 10 years. So if you calculate $4 for 10 years, you know how much million that will be? So that is why when you are picking any instance, you want to consider price. By default, when you pick an instance, you are going to be paying with what we call on demand. On demand simply means you pay as you go. You pay for exactly what you use. Pay as you go. And you are not going to like pay anything upfront or minimum contract. If you use it for 1 hour, you're going to pay for the 1 hour. If you use it for 10 hours, you're going to pay for the 10 hours. If you use it for 2 seconds, by the minimum AWS will charge you for is for the first one is 60 seconds, like 1 minute. That is the bare minimum. Even if you use it for 2 seconds, if you use it for 10 seconds, 40 seconds, 16 seconds, you pay for 1 minute. And after that first 1 minute, any one or any time, any amount of time you use it, that is what you pay for. You pay per seconds. So with a minimum of 60 seconds, but the bill increased 1 second increment. So the first 60 seconds, they are going to, even whatever seconds you use, once you reach the first 60 seconds, that is when they will now start counting in seconds. But before that is 1 minute, first one. So if you use it for 1 minute, 2 seconds, you are paying for 1 minute, 2 seconds. So what does that mean? You only pay for what you use. And you don't pay upfront. When you finish using it, they will calculate how much you've used, and that's what they're going to charge you for. And this is ideal for if you know that you are going to run a system for a very short period of time, then this is the best option. If you don't know how long you are going to use the system, you just want to start using it, this is the best option. And they call it on-demand pricing. On-demand pricing. That is not all. This is the most expensive form of pricing on demand. It's the most expensive form of pricing. There are some cheap options that give you discounts. And one of them is called the reserve instances. This one, if let's say you want to use a server. Oh, I was not paying attention to time. I didn't talk about break. We're going on break now, guys. Let's say you want to use this server for, let's say you create one server and you want to use it for, you want to use it for 1 year. If you are doing on demand, they are going to charge you, let's say the server is $1 per hour. So if you are using on demand for this one server for 1 year, that means how many hours in a day? 24 hours multiplied by 365. That is how much you are going to pay. And how much is that? Let me use my calculator. That is going to be 8,760 for 1 hour. That's what I'm going to pay for one 1 hour instance. So if you are using reserve instance, then for that same 1 year, they are not going to charge you $1 because you are now going to, you're now sure that you're going to use the instance for 1 year. They are going to give you at least 72% discount on this $1. So now, instead of paying $1, you are going to pay something like 0.28 cents for that same one server. Multiply that by 24 by 365. And how much is that? That is how much? 2,453 approximately. So now, which one of them is cheaper?
Reserve.
It is reserved because you are reserving it for the whole 1 year. You know how much you are going to save if you are using reserve instance. You know, company doesn't use one server. You will see a company that has almost 800 servers. You will see a company that have thousands, almost 3,000 or 4,000 servers. So if you are saving this huge amount on one server alone, you know how much you are going to save on 3,000 servers. You know how much you are going to save on 10,000 servers. So reserve is more cheaper, but one disadvantage is that you have to pay the money upfront. You have to pay upfront. So you have to pay this amount upfront. But this one, you don't pay it upfront, you pay it every month. You pay it every month. But this one, you have to pay for the reserve instance, you have to pay the whole 2,453 upfront before you start using it at all. And this is just for 1 year. If you want to use it, if you want to reserve for 3 years, it's even going to be more cheaper. It's not going to be more cheaper. So you can do discount. If you use the reserve instance, they are going to determine, are you going to reserve it for 3 years or you want to reserve it for 1 year? And whichever one you use will determine your price. The next option is savings plan. And with that, you can save 66% discount. And that has 2 options, complete savings plan or EC2 savings plan. And it's the same thing. This discount is on demand. If on demand is $1, then 66% discount of that is going to be 34 cents. That's how much you are going to pay. Then the last one is the spot instance. And with this one, you're going to save 90% discount. But the advantages of this one is that you can only use it for a workload that you can stop, and then restart it later. The reason why for that is that because this is like a bidding, because AWS have a lot of servers, right? It's not all the time that they have people that uses those servers. So let's say AWS have 3 servers that nobody is using currently. They don't want to just have them there. They were like, okay, bid, how much can you pay so that I can use this server? Why nobody is using it? If you tell them like, okay, I can, initially this server, if somebody is using it, normal price is $1, right? For 1 hour, each of them. But because nobody is using it, you can now say, okay, you know what? Let me give you 1 cent. Because nobody is using it, so let me use it for 1 cent. What is charged for $1? You want to use it for 1 cent because yes, it's still going to be profitable for AWS because nobody is using it. That means they are losing $1. But instead of them losing $1, you now say, okay, let me give you 1 cent. At least they are still gaining 1 cent. You know how much server they have? If they, let's say 1 million, 1 cent, that's a lot of money, right? At least it's still going to get them $100,000. So now, but the disadvantages of this is that if somebody comes and say, okay, since nobody is using this, I will pay 2 cents. For each one, AWS, they are going to collect it from you. That, hey, wait, we have somebody that want to pay higher amounts. So give us our server. So they give you 2 minutes. I think it's 2 minutes, if I'm not mistaken, for you to take off your workload off it so that they can give it to somebody that's going to pay higher money. So that is the disadvantage. But for this huge discount, is the best option. But you can't use it for workload that must not be stopped. So you can majorly use this for maybe you want to run a batch that you can stop, and maybe when this person that want to use it for 2 cents finish his work, then you can resume your own. So those are the pricing options that AWS have, and those are very, very important. There is one called dedicated instance. So this one, that is more of like, okay, let me quickly explain this. When you spin up a server on AWS, I've been calling it server. When you spin up an instance on AWS, that instance is not running, okay, it's actually running on the server, on the physical server. So let's say this is AWS. Okay, let me draw a better diagram. So now, AWS have data center, right? And in that data center, they have a lot of servers. So if you now tell AWS, hey, I want to use your server to run my application and I'm going to pay for it. And you say, okay, good. We're going to let you use this server. And you give them all the information that they need to create the server for you. They are not going to give you this entire server for you to use. They are not giving this entire server for you to use. On this single server, they are going to put multiple customers. They are going to create your own instance, your virtual instance. They are going to create it on this physical server. If I also use AWS, they might also create my own on this physical server. It's done. Use AWS. They will also create his own on this physical server. So 3 of us are sharing this physical server. But to you might be thinking, oh, because I'm using AWS, I'm using one of their physical server. No. If you want AWS to actually give you a separated server that nobody is sharing with you, that is when you are going for physical host. You are going to specifically tell them that you need this server to be on a physical host. So that way, nobody is sharing this with you. You are the only one that's going to use the host. So it's still going to be a virtual machine they are going to spin up, but they are spinning it up on a physical server that is being used only by you for one application. If you use dedicated instance, this is where AWS will spin up a server for you, but on this server, they can spin up multiple instances for you. So it's still going to be your own, but here can take multiple instances. So if you require 2 AWS EC2 instances, the 2 instances can be deployed on this physical machine. If I requested for 1 EC2 instance, they can't put my EC2 instance on the same machine with yours. They have to put it on another one that is being shared with multiple people. So this is different between dedicated instance and dedicated host. Dedicated host will use a physical server for one instance, while dedicated instance will use one physical server for multiple instances for one customer, for a single customer. So if you are using dedicated host, that means the price is going to be high. And company use this for maybe they want to run an application that cannot share the physical host with another customer or with another application. Then they have to go for physical host. So let's go on break. So when we come back, this is actually the first part of the class, and this is the end of the theoretical part for the EC2 instance. So when we come back from break, just 5-minute break, and I think we have like 15 to 20 minutes after that, then we are going to start the hands-on, which is going to actually spin up our own server. And I don't know if we are able to connect to the server today, but we're actually going to see what are the ways that when you get a requirement on the job, how do you go from gathering requirements to architecting that requirement and to spinning up the server, then test it to make sure that your end user or whoever requests for the server can actually connect to it. Then at the end of the day, we are going to terminate everything that we create. All right. Do anybody have questions before we go for the 5-minute break? No? Okay. All right, 5-minute break. All right, welcome back, guys.